morning. Welcome back to the conference for the second day. My name is Ling Lam, a faculty in the School of Creative Media. So today in this panel, which is a very special panel, I would say, because for the conference we have the theme of AI and art, and most of us are the users of these very cutting-edge AI and these cutting-edge products from computer scientists. But today, in this session, we are having two very distinguished speakers who are the inventors of these new kinds of tools and medium for artists. So it is very important and very good experience for us to listen from the inventors' speech and from their perspective how these research area can bring about to us and what is their objectives and driving force in pushing the boundary of this domain. Okay, so for the first speaker, we have Professor Huamin from the University of Science and Technology in Hong Kong in the Department of Computer Science and Engineering. Professor Chi is a very distinguished researcher in the area of human-computer interaction and data visualization with a strong focus in urban informatics. He's an award winner for many venues, and today he will be talking about data visualization and storytelling and a very emerging field that is called explainable artificial intelligence. So I will pass the time to Professor Chi.
Yeah, so thanks for coming on Saturday morning. So it's 9:30 is considered quite early in Hong Kong. So my talk is data visual storytelling and explainable AI. So I come from another local university. So it's HKUST on the seaside. So as you can see, this beautiful view. So I lead a visualization lab, so about 30 people, and it's including 20 PhD students, work on various things related to this data visualization, human-computer interaction, and also artificial intelligence. So the topic we work on include this kind of urban informatics, smart city, social media, and text analytics, and also the e-learning and the social network, AR, VR. So quite broad topic. And I also do something related to art, and I write an article for IEEE Potentials called Technology Meets Art. So we run a joint course with China Academy of Arts. China Academy of Arts is just art school, it's one of the top 2 or 3 art school. We are more like engineering school. So we run a summer course. This is about 8 weeks and 4 weeks, and with 20 students from art student, 20 from technology side. Then we mix them, and then to solve different problems, use design thinking. So 10 students usually is from medium art. So we work together, and also some work and exhibited in different places. So this is one of the work called Invisible Hand. It's use this kind of visualization to show its censorship in China's Weibo and the social media. Some Weibo they post, that is deleted, then some website document is deleted Weibo, then we do some kind of work to show this. So I think this main audience may not familiar with the data visualization. So what is data visualization? We said data visualization, input is data, and output is visual form, and the goal is just want you to gain insight into the data. For example, this one shows how Trump won this US election, and 3,000 counties, and this basically is you either vote for Trump or Hillary, and red one is for Trump, blue one is on Hillary. So it's just visualization shows the election results, and the inside is just this line, okay, Trump win by this, the middle, rural areas, and Hillary is just mostly in the city, so this is about the inside. So why you need this kind of things? And this is show some data, is designed by, some mathematician. So we have 4 data sets. If I ask you what's the difference between the 4 data sets, and you may not have a clue, right? Even give you 5-10 minutes, you may not see something. But I said, don't worry, I know statistics. But this design, the data that designed this way, so no matter what you do, the mean of x, mean of variance of x, all these statistics are the same, exactly the same. So basically, this kind of mining algorithm tell you 4 data sets have no difference. But once you show in visualization, immediately clear, right? Less than 1 second, you know, okay, what's going on. And so this is actually very, very powerful. We have humans visual channel can digest a lot of information in parallel. And so this is in Obama's Big Data Initiative. They mentioned about we need a data visualization to teach college students to use data visualization, analyze data. And even in this AI, and this is called United States is AI R&D strategic plan. They give 7 strategies for AI development. So the second strategy they mentioned, they will need to develop this effective method for AI-human collaboration. So how to make AI and human collaborate. And one thing is you need a better visualization to understand and the data generated from this kind of modern method. So what is considered good visualization? And this is what I listed here. So in visualization is some kind of translate from one media to another, from data to visual. And there is this called the principle for translation. And in Chinese, quite famous, it's called 信达雅. So I think is you first be accurate, and the second it must be this kind of intuitive, efficient, and effective. And last one is aesthetic. So aesthetic is more related to this is art. So some data visualization is also exhibit somewhere. For example, left side is basically a work by MIT Media Lab. It shows how a Wikipedia page is edited. Someone edited, someone changed the back, doesn't like it, so back and forth. Then you generate this kind of layered things. And look at some kind of aesthetic. So it's exhibited in some art museum. And the right side it shows, okay, this is evolution of species, something like that, called life of a tree. And this is actually shows in the Shenzhen, so our neighbor city. In Shenzhen MTR station, so it's just they consider this is beautiful and put on the wall, and then they say, I know, okay, the developer of this tool, and so he basically showed pictures, and he's very interested. Someone sent to him. It's in the Shenzhen subway station. They consider it's beautiful. So in our own research, for example, we design different this kind of data visualization. I want to make an aesthetic, so we borrow idea from this infographics. And this is a paper published in our top journal. It's called the Loyal Tracker. So visualize this loyalty dynamics in search engine. So they want to figure out, okay, how people use Google, how people use, this is Microsoft's, the search engine. And then, okay, we generate this kind of graph. But how this graph come from? They come from this infographics. And so I won't go to detail, but this is something we often inspired by this, the infographics designer, and see any idea come from that, then we do this kind of things. And also this is another work, so it's called the visual diagnostics of assembly line performance in smart manufacturing. So this is called Industrial 4.0 smart manufacturing. So all the data in assembly line is collected, is analyzed, and shared. and to all stakeholders. So it's called the smart manufacturing. So this one, you see all this kind of part, and the part may go to more than 100 different workstations, and in each workstation they do something, and sometimes just take 1 second, 2 seconds, or 1 minute, and then move to next workstation. Then the issue is you want to monitor all these kind of parts and how time in each workstation. Then how you visualize them, right? And they generate this kind of a design, and this design is how they got this kind of design. Actually, also inspired by this is at early days. This shows a train and the timetable. So like a train is each line is basically a station, and each this kind of sloped line is a train. So it's a train that goes to each station. Then horizontal means it can stop there. Then it's just move on. This one you can basically from slope you can get the speed. And each this kind of horizontal line period indicate the time. So let me play a show video. You can see how this kind of things, early days train timetable can be used to show. Okay, now this modern day assembly line. So
hello. In this video, we are going to introduce you to VidX, a system supporting visual diagnostics of assembly line performance in smart factories. We are going to demonstrate the system to you with a prototype web app we've built. The system supports both historical data analysis and real-time monitoring based on data collected during the operation of the machines and assembly lines. We will walk you through the individual components in the system.
Yeah, so you just got some idea, right? So this kind of assembly line, this kind of trace the time they stay in each station. And so this is very similar. We got this kind of idea. And also this one is called the storyline. They basically in the movie they say, okay, which actors they often appear in the same scene. For example, this Star Wars in this scene, which actors appear here. But this one is usually drawn by artists, right? You draw and it's then got each movie and you need to do it. And manually, so it's quite tedious. So our computer scientists, what we do is we automated the process. You upload the data, any movie data, then they can generate this kind of layout, and you still have the storyline. But now is you no longer need to do this tedious work by yourself. So this is the work is done by the UC Davis, and a bunch of work and try to automate this whole things. For example, how you generate this kind of infographics, and you want to be accurate, be aesthetic, and be creative. And for us, we're more concerned about the accuracy because this one you want to convey the data. How you can generate some kind of tool for infographic designer and to basically can accurately convey the data. So this is a paper we published in Kai, and this one is embedded in Power BI to allow you to visualize data in more creative way and also is an accurate way. So this is more like we said is infographics, and it's more like is just traditional way. And this is a system we developed to show how this is a twist, and is basically retweeted in this the Twitter. So it's called whisper. Is when where a story dispersed, and this one is a design we think is more creative. So this is if you go to Twitter, right? So there's a lot of tweets there, and someone maybe retweeted another one's tweets, and sometimes even retweeted multiple layers, and A retweeted B and B retweeted A, and also some tweets maybe retweeted tens of thousands of times. And but if you just look at this kind of layout, you may lose some perspective. And basically, they only show you this is a linear order, right? But how you can do better, right? So how we can basically represent this dynamic information diffusion process, and when it's retweeted, and then peak hour, and who retweeted, how the community respond to the tweets, and whether it's positive or negative. So this is we basically borrow, inspired by the sunflower. And if the sunflower, we think we found some similarity here. For example, the sunflower have seeds, right? If seeds is not matured, it's basically in the middle. If they matured, then they become matured. Then maybe it's blew to another place. then you can basically grow to another sunflower. You have their own life. So based on this observation, we basically lay out the twist just like a sunflower. If a new twist just come out, it's just in the middle. And if no one retweet it, then it will basically, the phase out will be died, there's no on life, then will be disappeared. If we retweet it, then we will put in the out layer, and this one will be, will move into, the group who retweeted, then its own have its own life, right? So this is called, the metaphor. We use this kind of metaphor to this kind of design. So this shows the interface. So right side is a list of tweets. The middle one, okay, the tweets, and also people retweet this kind of tweets. Then the color indicates the sentiment. So it's the red one is basically negative sentiment. The green one is a positive sentiment. So here is just the video, and it basically illustrate how it works. For example, if you input some keywords, like this Obama, and this is then okay, all the tweets start to pump out. If new tweets related to Obama is appear in the middle, and this kind of sunflower. Someone retweeted will move from middle to this kind of out layer. So each of the out layer node is represent a group who retweeted this one, and then you can basically monitor and see this what's going on here. So this is you basically can see okay here, and more tweets come out, and then this shows okay different country, and these tweets are basically retweeted by people from which countries. This shows a dynamic system and how it works. And also this is each circle represents the time range. So basically from this one you can figure out how long this one has been retweeted. So once you have this kind of things, then this kind of design, the next one you want to generate a layout, right? So this kind of layout, and we need to solve this kind of partial differential equation, and then basically figure out this kind of diffusion, the pathway. Then I think there are the algorithm side to generate this kind of layout. So I just skip the details. And from this kind of visualization, you can immediately figure out something quite interesting, because this twist is about Japan, right? Japan earthquake. So once you have earthquake, usually people worried all this kind of negative news, and the home is destroyed. People died. But then you can see some kind of green one, right? The green one means okay, positive. So why okay in earthquake there is still some kind of this kind of quite a positive news? Quite positive twist. For one green one, we click it, then this one shows from Thailand. Then we found out that there is a movie star is in Japan, so there is an earthquake. He basically post some tweets, okay, said everything is fine, I'm okay. And then his fans is so happy and just retweeted a lot, then create this kind of things. Then it's from this one, we can see can use it for the monitor the tweets. So we also do something for the WeChat. So this is something we developed for WeChat. So WeChat is just like WhatsApp. In China, it's have 500 million users. A lot of things going on. And this is show some article is widely read. And also they basically is worried about the fake news. So the fake news is a big issue, right? In this in US and also in China. And they want to figure out, okay, how this fake news, is spread on this kind of social media platform. So this one is covered by, it's called the Tech in Asia. They basically see how is China's WeChat, handle this fake news differently from Facebook. So this shows some kind of system we developed for them to monitor how is very, popular articles or this kind of posts is basically diffused or spread on this kind of WeChat platform. So next I just add a short video to illustrate how this system works. Yeah, so this one is shows, okay, some kind of tool we developed to monitor this kind of information diffusion. And so this I mean, the conference about the machine learning and also the art. And so from the machine learning and also the data visualization, so there are two directions. One is called AI for visualization. So how we can use artificial intelligence, machine learning, to automatically generate this kind of data visualization. So then you can avoid this kind of tediously adjusting by yourself. And so this every year I run is called the top visualization competition among my students or in my course. So this year I think the winner is this work, and this I think maybe is well known. I don't know, but it's definitely not a visualization. But our students still feel fascinated. So the idea is this is how this kind of a computer can generate art. So they generate art, just collect this string. Okay, see all this one just a line. Okay, just okay, different points they collect this kind of string, and this kind of string then they form this kind of art, and the student feel it's quite creative, and also it's something quite unusual from what a human generated. So they feel okay, this kind of computer and with algorithm, this can be quite creative. So this is the open source for how, I mean, in the future, how we can use this kind of AI to generate new, I mean, data visualizations, which more, I mean, creative, more novel, and basically is beyond the imagination of human. So this is one direction. So another direction is called visualization for AI. How can you use this kind of visual form to help people understand artificial intelligence? And this is a new hot topic called explainable AI. So what is explainable AI, right? So now is this AI system is just like often say the black box. When we go to this deep neural network, it's become more and more complicated. And then it's just a very deep neural. It's can be more than 100 layers and millions of neurons. All these one connected. And so you train this kind of neural network. What you get is just a bunch of numbers. How is the neural? What is the weights? How they connected? It's hard to understand how they make decision, right? So this is basically the cartoon shows, okay, this guy is tuned his AI machine learning model. They said, what is your model? And it just turn this, stir this kind of data and algorithm until something looks right, come out. Then this guy asks, okay, what's going on if it's done, done looks correct? Then just keep trying and until it looks correct, right? If no, and hard to understand, okay, what's going on, and also you are not sure whether it's really, I mean, correct or not. So this is the topic called, I mean, explainable AI. So the idea is, okay, you want to make this kind of artificial neural network is more understandable by human. So not all applications need, I mean, explanation, right? Like you do the weather forecast, and most people don't care how you got it, as long as it looks okay, right? But for some things, it's in high stake. That is, we should definitely care. For example, the fairness. If the AI system said, okay, we use it to admit students for college admission, then you just worry about whether we should do something and understand the system, see whether it's basically biased toward a certain, I mean, group. Right? Whether it's a bias toward, I mean, I don't know, it's some minority groups. And also for this kind of judgment, right, for its law. And if you said AI makes this kind of prediction, this guy may commit a crime again. And whether we trust it or not. So this is about the fairness. So we need to care. We need to understand how this artificial intelligence system works. Another one is the safety. For example, automated, I mean, vehicles, and then you need to understand the risk, right? Basically, is when it may fail, and which scenario the risk is pretty high that human may take over. So also need an interface, right? And also is for this kind of medical diagnosis, you cannot totally trust AI. AI said, okay, you got this kind of disease, you want to understand why, right? So, and also, you have this kind of law. So now European Union have this new law. It's called, I mean, the General Data Protection Regulation. That in Europe, if you want to sell some AI product, And if end users ask for some explanation, then you must provide this kind of explanation. So this is the right to explain, okay, to explain something. This is for a framework for transparency rights and the right for explanation, and also to contest a completed automated decision. So then if you want to do this, and you need to provide the AI. So what is explainable AI? So for example, this neural network tell you this is a cat. They just tell you a result. But if you want the explanation, it said, okay, this one classify this as a cat because they have this kind of feature. They have fur, they have whiskers, they have claws, and once you see this kind of feature, then okay, they classify this as a cat. This is called explanation. And then you can better understand how they come out with this, the decision, right? And so this is this explainable AI is not to try to understand everything and about the model. We just try to understand how AI arrived at a specific decision. Okay, how AI make this kind of prediction, make this kind of recommendation, and this is called the explainable AI. So what is explainable AI? We want to ask for this kind of algorithm transparency. We need a global model interpretability, and need a modular interpretability, and also need a local interpretability. We want to interpret this kind of model is better. And the model algorithm transparency is how does the model learn from the training data. So I don't go to the details. And also this is the model interpretability. So how does this trained model make decision? And this is a rule-based. A rule-based people can easier understand. But if a neural network is black box, it's hard to understand. So this one is later we show you some example how we try to solve these issues, and also how do part of this model influence the predictions. And this kind of technical detail. And this one, how does this model make specific decisions for a single or group of instances? For example, this one said, okay, I give this kind of image, and then the artificial intelligence model, AI model, tells you this is the image about the cutting tree. But why they classify this one as a cutting tree? So this one shows, okay, this kind of major features which influence the decision, because they recognize this kind of features, recognize this the human eyes, and recognize this here a saw, and recognize something else. This one is said, okay, because these features, then they come out with decision that this one is human cutting a tree, right? So our group have done a bunch of work use this kind of visual form, and some part of this we think is aesthetic, and then try to use this one to understand the deep neural network. So one work is we work with Microsoft Research Asia. We develop a system. It's called Deep Tracker. So visualizing the training process of a convolutionary neural network. And this is just try to the training process. The main user is just about the programmer try to debug their model. This one is called RNV, try to understanding the hidden memory of recurrent neural networks. So the Yelp is every year they run this kind of competition. Any papers, any research project, if you use their data set and do something, you can submit your work. Then they have a judge to say pick up the winner. So actually we are this round 10 is 218, is grand prize winner. This first time this kind of prize given to a team is in Asia. So what we do is with Yelp review data, we use this RN model to train it. Then after that, we figure out, okay, all this kind of hidden unit, what is it about? And before they don't know what the hidden unit about, then we do some work. Then we cluster that this bunch of hidden unit actually is respond to this positive, review words, positive, words. And this group unit actually respond to negative words. And then now this kind of hidden unit, previously just some number, now you can better understand because now it's basically say how it's sensitive to what kind of words. So this is the work we've done with NYU. It's called the rule matrix, try to visualize and understanding classify with rules. And the basic idea is okay. Some model is hard to understand, like deep neural network, but some model is you can easier understand, like rule-based. And so this is the rule-based. They call it decision rule. Okay, if this xy less than 4 and then less than x2 and x3 equals 3, then the probability equals 8.8. So this one I think people can better understand. It's just some kind of rule. If this happens, then this the results. And later we should show you example. So this rule is easier to understand. But some things is hard to understand, right? Like neural network. So what we do is we use something you can easily understand to approximate something hard to understand. Then, okay, based on that, every time this hard to understand things do some kind of classification, prediction, whatever decision making, then we use this easier to understand to approximate it. If this both got the same, the result and also the accuracy the same, then now you can basically you basically trust it, right? Because this one, even the neural network is hard to understand, but this rule-based give you the same results, and this is how this tell you how they make the decision. Now you understand this as the result the same. If not the same, then we tell you what's the difference, accurate difference, and what kind of feature, and make it hard to understand. So it's called a rule matrix, and so this is a list of bunch of rule matrix. So I think is maybe I play a video so see how this kind of system works, how this kind of visual arts and help you understand the neural network. So I just play a video to illustrate this whole system. Yeah.
Model, trying to understand what model has learned from the data, wondering why the model gives the prediction. Rule matrix is designed to solve these problems. It is a technique that helps you visually investigate the behavior of a given classifier. Rule matrix use rule induction techniques to extract the rule list that approximate the given model. Then we use the rule list as an explanatory interface and present it using an interactive matrix-based visualization. So, how it works? Here is the pipeline for building up the rule-based explanatory interface. For a given machine learning model, we first extract the rule list from the model using a rule induction algorithm. The rule list serves as a simplified representation of the model. Then we use visualization to assist the understanding, navigation, and comparisons of the rules in the list. When the list is too long, we use rule filters and data filters to reduce the number of rules to show. Here, a rule list is an ordered list of decision rules. Each rule contains an antecedent and a consequent. The antecedent, that is, if, is a conjunction of multiple clauses. Thus, we only has and in the rule, and the rule will only fire when all the clauses in the rule are satisfied. The consequent, or the output of the rule, is a probability distribution of all possible classes. Since the rule list has an ordered structure, the rule will only be consulted when all its previous rules are not satisfied. The interface contains 4 components: the control panel, the rule matrix, the data filters, and the data table. The rule matrix consists of 3 parts: the data flow, the rule matrix, and the support view. In the rule matrix, each column represents an input feature. Each rule in the rule list is visualized as a row in the matrix. Each clause in the rule is visualized as a glyph in the corresponding cell. Multiple conjunctive clauses are visualized as multiple glyphs in a row. The range used in the clause is represented by a transparent gray box. The data distribution of the feature is also displayed as a histogram. This clause represents x larger than 19 and smaller than 36. The output of the rule is displayed as a colored number. The color encodes the predicted label of the rule. The number is the probability of the predicted label. The data flow shows the ordered structure of the rule list. The main vertical flow represents the data that remains unclassified. Each time the flow encounters a rule, a horizontal flow forks out. we'll be presenting a part of data satisfying the rule. The support view visualizes detailed information about each single rule. The fidelity shows how reliable the rule represents the original model. The evidence shows the predictions of the original model and the real data. Striped boxes encode wrong predictions. We trained a neural network on the Pima Indian diabetes dataset. The model achieves an average accuracy of 72% on a test set. We use rule matrix to understand the behavior of the model. The first rule shows that if the patient has a high plasma glucose, the model will very likely to predict positive. This agrees to our knowledge in diabetes. The rule 2 to rule 5 show that the model would mostly give negative prediction. Go through these rules, we can conclude that the model thinks young patients with low body mass index is unlikely to have diabetes. We test these findings by using data filters. Now, the model almost predicts negative.
Yeah, I think it's because of limited time, I just stop here. So this will give you some idea and how we approach these kind of things. And still ongoing research, so we try to use this kind of visual form to help you understand, okay, how this kind of neural network, how is it trained, how they to make the decision, and how to do something like this. So this is about the explainable AI, and yeah. So this is we show the different use cases, and also we have a demo. So I think it's I just give you some brief idea about what is the data visualization, and also is we talk about the data, we talk about the visual storytelling, and we use some cases to say, okay, how this kind of visual form can help you to understand the data. And also in the future, and you can use this kind of machine learning to generate this kind of art. This art is not just aesthetic, not just inspiring, and also can basically solve some practical problems, some real problems. And like to monitor this kind of information diffusion, and like to basically see this kind of smart manufacturing. And also we said this is called AI for Viz, and also Viz for AI. These visual forms can also help people to design the better machine learning model, and help you debug the machine learning model, and help you understand, okay, machine learning model, and to make this artificial intelligence is more understandable, more interpretable to humans. So this is basically my talk. Okay, thank you.
So we will have approximately 25 minutes for discussion. So I will start with my questions, and then I will pass the time to the audience. Thanks for both of your very stimulating talks, showing the cutting edge and state-of-the-art result of your research. So I have a couple of questions, and the first one is for Huamin. Professor Chu. So you have been demonstrating the power of visualizing data, especially big data. But when we talk about big data, it's usually involving lots of parameters, high dimensionality. So for the human system designer, they have the full control and autonomy to choose what kind of parameters they want to show and interpret. So it becomes a question or a critique for the subjectivity issue. Yeah, because it becomes the artistic choice for the system designer, and it could be also a very dangerous and powerful tool for other intention, because the intention behind these visualization could be very complicated but implicit. So I would like to know if there is any quantifiable or measurable method to see how these visualized information are fair or complete.
Yeah, I got the question. I think it's a very good one. So When my student do this, thesis defense, this called PQE exam, so we invite professor from other area, like from machine learning and data mining from database. They often ask the same question, said, okay, you do this kind of visualization design. You design the sunflower, looks good, but how about something else? Another flower, animal, and so how you really measure, right, whether you succeed or not? So this is called the evaluation of visualizations. So I often give this kind of metaphor. The visualization system is just like this kind of, the magnifier. So if you have this kind of magnifier, you have some structure there. Then you look at it. If everything is right, then this pattern will automatically pump out. This is called amplify human cognition. So from this purpose, evaluation, visualization, there are multiple layers. So first layer, so this one must be evaluated by human. Human include the visualization expert. For example, visualization professors and practitioners. So this field already have more than 20 years. They already have a bunch of rules. For example, if we want to use animation to show this temporal data, it doesn't work because humans have this kind of short-term memory. And so this is another one is from domain expert. You want to help people, domain expert, to solve their problem, like monitor this kind of information diffusion in WeChat. The end user will also give some opinion. You come out with multiple designs, said, oh, I like this one, I don't like this one, I don't think it work. So this first evaluation is by this kind of human. The second one, we deploy this one, apply into some real data, like we basically plug in some big data, apply our system, then see whether it really helps them solve their problem. And you need evidence, say this one really found some patterns, found some stories in the data, really amplify human cognition and basically really shed light on something we don't know, right? So this is the second evidence we call case study. Apply them in real data, show evidence from real data set that it works. The third one is more quantified, quantitative evaluation called controlled experiment. So you have your visualization system and the domain expert have their baseline system. They use some tool and use, for example, machine learning algorithm, use some kind of like Microsoft Power BI, something like that. Or you have visualization design A and design B. You want to know which one is better. And then how we do this? We basically do this controlled experiment. For example, we recruit two groups of people, and one group use our tool, another group use a baseline tool. Then give them the same data set, give them the same tasks. And the only difference is the tool is different. And also for the user, we have two group user or one group user use same tool, different tools. Then we basically test. Okay, we measure their response time, the accuracy, see whether really have evidence shows our tool is better than others. So I have this different layer. So basically by the human domain expert, visualization design expert, see whether it's comply some rules, whether basically they like it or not. Then we apply to real data, see whether there is evidence it works. Then we do this quantitative evaluation, basically ask them to solve some problem, then measure the accuracy, response time, so whether their evidence show this tool is better than others. So there's different layer of evaluations.
But these are the tools or the measurement for how effective these data are being visualized. But how do we, as layman people, judge whether this information are only intended for a specific purpose, or, for example, if you show some data, the current amount of numbers, okay, but it could be a very totally different story if you show the rate of change of the data, like taking the time derivative of the same set of data. So it can be then intended for another purpose. So how do we judge whether these information are genuine?
Yeah, I think it's I think your question maybe the data is very high dimension as different data set is you combine them together. Then from 100 dimension, you can pick up 10 dimension, right? Do analysis, found some story. If you figure out another 20 dimension, you maybe figure out another story, right? Then how you pick up the right parameters and the right subset of data, then basically to solve your problem. So this one is in our visualization design, we follow a rule called overview first, zoom and filter, and then details on demand. So we first gather the overall distribution, let you see the whole pictures. And there are some tools that help you to visualize this high dimensional data. Even 100 dimension, 200 dimension, there are techniques called the parallel coordinates. And also you can use the t-SNE, MDS projection. In the Google's TensorFlow, they have this kind of visualization tool, let you to see, okay, this is a cluster in high dimension. So this is overview, give you some big pictures. Then you can zoom and filter. Basically, is there are also some algorithms help you detect the correlation in certain dimensions, and also help you find the cluster in sub dimensions. So then explore the data. You can zoom and filter, and then after you got something you are interested, you can basically fix that data set. Then next stage is details on demand. Then more details about this subset data. You can do in-depth analysis. And this process can go multiple rounds. And so another strategy to solve this problem is, that's why they train, okay, college students to use visualization solve problem. Then, okay, it's called open data movement. The government push the people but put the data online. Then have a tool online. Then everyone become a data detective. Then any people are interested, you can use this tool to explore the data. Then it's just kind of tens of thousands people explore data from different perspective, and also give you a platform to share your finding. And then this one use cross-sourcing, and to figure out what is most interesting combination, subset, and subdimensions in the data.
Thank you. So I would also like to ask Jing. So actually 2 questions for you. For researchers in general, especially for technologists and scientists, there are 2 ways to do research. One is we identify the problem and application, and then we find solution for that. And then the other way is we have developed some new technologies or methods, then we will then look for the problem to apply to. So I would like to know, in your research practice, or maybe in the past when you were in Microsoft, do you, for example, because your research are mostly on visual computing, do you work with artists and then identify the applications and problem, and then you tackle the problems, or in the way, yeah?
Okay, I would say both. Because for us set up the research topic, especially in Microsoft, we already know the problem from the product, or as you said, from some artist. They have that requirement, so we want to help them to solve this problem. And once the research has been done, we have some result, we will think about, is there any more applications can be applied with our technique? So this is, I think both were involved in my research.
Do you think you will still work in this workflow after you become a faculty member?
Yeah.
Because you might not necessarily get the information from commercial products and the needs in the market, right?
Yeah, but I still want my research to be applied to some real-world applications, to solve some real problems. So I still will looking for the problems that need to be solved.
Okay. And since we are in the conference in the context of creative art, so when you work on machine learning and specifically deep neural network, there is a common problem for most kinds of techniques is the result is highly dependent and sensitive to the training data set, right? But it becomes a issue for artists or designer or the creative community in general about how the extent of creativity that this tool can bring about. So, like, is there any direction or like in the research field that we can get rid of this limitation of like how the algorithm would be highly dependent on the existing samples, so that we can explore more possibilities and make the tools more creative?
This is a very good question because this is also a hot topic in the research area. Currently, the machine learning things all depends on the data set. But as you said, the data set is limited. So we will always want to create more data set with some technical method. The generative model, like the, as I said, the generative adversarial network, the GAN, is designed for that. For example, we want to train the face recognition, but we have a limited data set for the different pose of the faces. So we may use some network to generate the face with different poses, with different lighting, with different conditions, to increase the data set, to augment the data set, to improve the quality of the face recognition network. But this is controversial because some researchers still argue the data you generated with your GAN, with your network, is still inside the data set you already collected. It only do the interpolation, not the extrapolation. So it's still controversial. This is effective or not. But I think it's a very interesting direction to do some research.
Okay. So quite recently, there is a piece of art that is created by an algorithm like GAN that was sold in an auction house for over $400,000 US. So how do you both, as the inventors of this kind of techniques, see like the ownership of this kind of artistic medium and tools while being used by first creative purpose, but then there is a commercial and implication in it. So, do you find it a exciting piece of news or frustrating?
For me, definitely exciting because I'm working for that. Yeah, I'm happy to say that people will recognize, will like the painting generated by the artificial intelligence. But I know there's some controversial. But for me, I will still further explore the ability of the artificial intelligence to generate the better and better quality result.
Yeah, I think in our field, it's just a start on how to use this kind of machine learning, generate this kind of visual arts based on the data. I think for the IP issue is two factors. First, for this tool, right? If this tool itself very creative, you spend a lot of time design this tool, but apply this tool to the data is trivial, then the definite ownership should be the tool, right? And on the other side, if the tool is very standard, but the way, you tune the parameter and you basically apply the data, that the creativity is on that side. And then definitely, I think the IP should belong to these users because actually they use this general to create something quite unique, their style. I think about the IP issues.
So then there's also a more general question because it's also a intersection between art and science. And when we are talking about art-science contest, we hope to have the two culture getting benefits mutually. So artists and creative community are getting great benefits from the researcher, especially from computer science and machine learning. So how do you, in your experience and or in your vision, the creative community, like artists and designer, could also bring to computer scientists insights and inspiration and etc. For that helps the community for.
Yeah, I think our visualization is considered a sexy part of big data because it really involves kind of visual art. And actually this community, actually it's a two different community. One is more from designer point of view, and they basically design something really fancy and have a strong art, feeling. But it may not work because you look at it once it's okay, but if you daily use it to solve your task, may doesn't work. On the other side, is have engineering, and basically it's accurate measure how people do their tasks and develop some tools and may solve the problem, but they don't have art, artistic, feeling. So what they do is these two communities is try to build a bridge and to let them communicate more. And in my group, actually, we have this joint MPhil program, Master Philosophy program, between China Academy of Arts and also our, the computer science. So we bring some art students. Let's do something called Carol art and visualization. So this one is just like a piece of things you can hang on your office. If you don't know, okay, what is the encoding scheme, it's just like art. But if you understand what is encode, it may be just encode this daily stock market, price change, whatever. Then you basically get the information from it. So I think is either you train someone, have both background, you develop some tools, or you bring people together. So I think is we in our design thinking course and in our this dual degree program, we experiment with both. Then I think is currently we try to bring this people from art background, people engineering from system in the same office, and let them talk to each other, then see what happens. I think is the first batch with dual degree program with art and computer science. I think it will join my group in this semester and see what's going on.
And Jing?
For my work, the collaboration between the scientist and the artist is especially important because for us, I'm working for the technical part. I don't know many things about the art. So I worked a lot with and communicated a lot with the artists to ask their feedbacks about the things I generated. And with their help, I can gradually improve the quality of the things I generated. So it's very important. Another thing that all the tools I designed here, I developed here is for artists. I don't want to use the artificial intelligence to replace the artist's work. I just want to give them some tools to help them to create better artworks, to give them more freedom, to more convenient to do the artwork creation.
So now I would like to pass the time to the audience. If you have any question, please. Do we have another microphone?
Thank you, that was really interesting. I have a question for you, Jing, actually two, and again picking up on the art market question because I'm an art historian, so that's what interests me. So, I mean, if you say you want to apply these things in the real world, and the real world then would be the art market also, not only the artists, and we already touched on that a little bit, and I think how the art market works is very much on the idea of originality and also scarcity, and then also of perfection in terms of craftsmanship. So my first question would be, I mean, if you look into photographers or printers, what do? They work with limited editions. They say, oh, they destroy their copper plate after having printed like 10 pieces of a work or something. So they try to technically limit the works they can produce because they know if they produce too many, they don't get as much reward, as much money back. So if you see the final product as the most important thing, as opposed to the tool, which would be another approach, then you might want to consider also working with this kind of art market related strategies, or not you personally, but someone who uses this method in a way. And the other thing would be about like finalization of these products. So, I mean, now we saw, of course, digital images, but I know, as an example, the Van Gogh Museum in Amsterdam, they're producing higher resolution 3D prints, which really show all the kind of texture and things of the original paintings quite perfectly, I have to say. So did you think about these applications also?
Yeah. Currently, because of the limitation in this technology, the result we generate is still in the low resolution. As you said, we cannot in the fine artworks. But here, there's one direction of the fine-grained game. It's trying to solve this problem. We're going to learn lots of things about the fine details, fine textures, but it's still for the digital things. But I think with some 3D printing machines, 3D printers, it can be printed out into the physical fine artworks. Yeah, we will think about this application.
First question about limitations, limited editions, something like that?
Limitation for what?
Limited editions.
就是不要 produce 那么多，就是限量。
Oh, okay. Yeah, that will be a problem. Actually, to be honest, I have never thought about this question. Yeah, the first time I thought about that. Yeah, with the technology, it can produce a lot of things, but I haven't thought about it before how to solve this problem.
I mean, not to make this clear, I'm not a big fan of that idea. I mean, I appreciate the idea of more working on the open source tools, but still, if you want to have the art market as a client, that might be something to think about in the future.
Yeah. Thanks. Yeah.
Question here. I found your presentation really interesting, especially from a technical point of view. But it never occurred to me until you just said it that it might be an artist's tool. And I was surprised when you said, oh, you wanted this to be a tool for artists. And so that last question was talking about the value of art in terms of the market and limited, availability, enhancing desirability, and therefore financial value. But there's there's a whole raft of other forms of value in why art's made and how an artwork contains value. And for a lot of artists, speaking as an artist, won't speak for all artists. I'll speak for artists who work like me, I guess. The main reason you develop certain representational strategies and techniques and tools is not for their own reason, but to try and find new ways of seeing things. So that you actually, through manipulating these tools that by their nature are difficult and constraining, and you struggle with them, you end up with a way of seeing the world which is a way you've never seen it before, and you've never seen anybody else see it that way before either. And in a sense, for the artist, that is a kind of knowledge. Not a knowledge in an empirical sense, but in a sort of broad epistemological framework, it is a kind of knowledge, a way of understanding the world. And that's, I believe, where many artists find the real value of art. It's in that moment of revelation. Oh, I see the world in a way I've not seen it before. Everything's different. Everything is different because of that. That is sort of almost the opposite of what your system's doing, which is not trying to see the world in a new way, but taking an existing, what you call a style, a way of seeing, and applying it to, as just images, whatever they might be, converting them into that style. So that leaves me wondering how that could ever possibly be an artist's tool, given that an artist is looking for the novelty of seeing, not applying a way of seeing to a novel image. See, it's the other way around. I don't know if you'll make a comment on that.
Okay, I think it will help in two ways. The first way is that, as you said, it will simulate something. It can reproduce something. So if we can make it interactive, that will make the artist to create the artwork more easier. Because some of the replicated things, there's no need to do it.
Yeah, but that was sort of the point I'm making. The artist actually doesn't want it to be easier, they want it to be harder.
Oh, really?
Yeah. Okay. So the harder it is, the better it is. Yeah.
Really, but I have communicated with some animator. they will have to draw lots of the frames in the animation. They don't want to draw every frame. They just maybe want to draw one frame, and then they want to automatically generate all the other frames. So I think for these things, it will be helpful, and it will make the production of their animation more efficient. Another thing I think this is helpful is that although now it's all, the technique, the method only learns how to simulate, how to do some interpolation of the existing styles, but the interpolation sometimes creates some new styles. For example, in our data set, if we have lots of the styles, with the Van Gogh styles, with other some Chinese painting styles, it will do some interesting interpolation. Sorry I haven't shown here, but I have saw some effects like that. It can do some combination and the interpolation. I think it's another kind of the creativity. It's not just a simple reproducing. Okay, thank you.
Yeah, also I have one observation, so I just very short. So I think you're right. So basically, artists should look at the way, a new way to look at is our life. But now in big data area, many of our life, right, activities are data driven. So we basically say, okay, we live in this kind of social media, how we interact with each other. For Amazon, how we purchase book is hundreds of dimension of data there. And if artists don't even understand, okay, what the data means, don't even grasp the tool to basically understand this kind of data, then how you basically can look at this from the new way, right? It's a new way of life, we live in this kind of data. So that's why we try to develop some tools to let you explore this data by yourself, then you may get a new perspective of human life. Then you may generate a new kind of arts to basically deal with our modern day life.
I have a rather specific question because I think it's very fast. It will be the last question. Sorry. Okay. But it's a very small question. So, I really like the idea of the role matrix that it seems to really bring forward the sort of hidden process of a neural network. But I just wonder, because it seems like it just translates the classification result of the neural network into a probability model, and I just wonder how like algorithmically it really connects to the network. Like how is it a sequential process or a parallel process, and how exactly it translates the calculation result of the neural network into this probability model? Because if it seems to me like I like the visualization part. I don't quite figure out how exactly it connects to the neural network, like how the rule matrix connects to the neural network.
I think we have a multiple work. Some work deal with dynamic evolution when you train the data, how this neural change, how the connection, which connect get the strength. For this, rule matrix, what we do is just based on the results. So the result is, okay, you got some bunch of data, then the data have features, right? So have item, have feature, then you train this neural network. Then any new instance come out. For example, I give a new patient record, I give you a new image, then the neural network will give you some results. And this rule base will give you some results, right? And then we basically say, okay, is how they align, whether they align, right or not. For example, if both say, okay, this one diabetes, and the accuracy is quite, high, then we basically have a way. Neural network just tell you have diabetes. Then we tell you because the rule A, rule B, rule C, and tell you have diabetes. But on the other side, for example, some part you are right. Some part of this neural network is why it's better than rule-based because it's more, have more capacity. And so in that case, what we do is we said when the neural network do this kind of results, right? Then from the training data set, which features actually have more influence on this neural network and make them to make this classification. And if you look at the video, I have give one example. For example, some woman, they have middle age, high glucose, and then something, that have some another feature. Then this one accuracy is not high, and then we basically narrow down to some features. This kind of feature actually make a neural network is less accurate. Then we can do something to improve it. So I think this is quite a challenging issue. It's still hard research topic. because this one is someone even argue, okay, by nature it may not even interpretable. Even our human don't understand why we make certain decision, right? And I think this is with this still a very early stage of work.
Okay, thank you. We will end this session and have a coffee break downstairs. So if